and welcome to Datron Tech Day 2023. We are about to welcome our first guest, so let me give you a quick tour of all the technology and solutions that we have around on display. We are here at our Datron Tech Academy, where we have all the machines that we have in the portfolio on display, just like the MX Cube in this version with a 4 kilowatt spindle. What we have on display here is this is like a sample part that shows the dynamic and the capability of great surface finishes of this machine, because this machine is super rigid. On the other side, we have kind of the same machine, but just with a stronger spindle. And what we do here is this model of a massive turntable. So there's a lot of chip removal, also a great fit for the machine, as it comes with chip conveyor. It has a lot of solutions inside of the machine, just like blow-off nozzles and so on, that just keeps the machine running. When we go over to the ML Cube, that's a machine that has been around for a few years now. It has the widest X range of all our machines. We have 1 meter in the wide travel that we can use, so it's ideal for like big vacuum work holding solutions. But whenever you work with this machine, you might have come to the point that because of the size, it's kind of difficult to reach in towards the end. So it's because of 1 meter in Y, you need to be very tall so you can reach the end of the vacuum plate, just in case you have plates there. Also, the chip management, it was up to now with these kind of trays, so it's like a big box that we can draw out with smaller boxes inside. As this machine is extremely useful for us and our customers, we have thought a lot about what could be improved. And the result is a machine which is currently a concept machine that has more or less the same dimensions of the ML Cube, just with everything that we've learned at the MX, like the chip conveyor and so on. So we've improved this machine. So here is a brand new machine concept of the ML Cube. As you can see from the outside, it looks completely different. You can also see there's like an external terminal. And we have an auto door, which means instead of like folding up on the front, it now opens to the left and right. So we can very easily reach into the machine. There's even a step that we can take here. So we can reach into the machine. It's open to load it from the top as well. It comes with a chip conveyor, so it automatically, like the chips will fall down on the conveyor and will then be just transferred to a chip wagon externally. So it really breaks down the downsides of an ML Cube machine concept. We are very excited about your opinion of that. But also with the external terminal, we have now the capability to bring machines, no matter if it's an ML Cube or any other machine, into like robot cells where you cannot have the terminal and the control inside the cell. You need to control it from the outside. Now, when we talk about machines that are ready for automation, the next logical step is automating a machine with a handling system. So here is a concept of a Datron Neo with a small robot that handles parts, that loads and unloads the machine, but also turns them around. So we have a multi-site operation. So what's happening here is I'm having these stripes around the machine. You might have already seen that. There's like a red and white one, and there's a further outline, which is yellow and black. So we have two warning zones, or we have two zones, safety zones. We have the outside where the robot would go in full speed. This is not the maximum speed of the robot, but it's set now to 40%. So if we see it handle and I'm outside of the machine, it goes full speed. If I step in now, it slows down, and if I get closer, and move into this safety area, it comes to a complete stop. So that allows me, because of this scanner, to work with the machine in a normal environment of a machine shop. What we're doing here and want to demonstrate is how we can automate a standard machine, which this Neo is, with such solutions, maybe into a hybrid form. So the day over you would work manually, you would load the machine manual, and like say overnight you can run this in an automatic mode with a tray. We're doing these little dice here with different engravings from each side. So it's a full 6-side operation. We start with a full stock part, and it would rotate the part around and reload it every time. So I'm stepping out again so the machine can move on. You've probably noticed this little camera up on the roof, and there's a second one right inside of the machine. The reason why we have those cameras is that we want to expand the limits of our Datron Live app. The Live app and the REST API is a tool where we can get access to machine data, no matter if it's a runtime, a state of a tool, but also, as we have the camera inside of the next machines in the standard, we're expanding more camera angles. So let's just come over here where we have set up a screen with a computer. We can now see the live view of that top view camera, but also of the inside. The standard camera is just giving the top view just for locating the machine. But now we can see what's going on the inside as well. So this is also an option now to equip machines with multiple cameras, just to get you a better feeling for like process, stability. You can just like watch remotely and so on. Now when we talk about small robots like on a Datron Neo, we can also equip the bigger machines and the larger format machines with then bigger robots. So this is not just any handling system. This is a plate handling system that is very unique. That is one of our own. That's an own development of us, and it has 2 working principles. The idea behind is that we can grab a vacuum cart, load it to the machine or bring it to the vacuum table, then pick a plate, different size, could be different thicknesses, and both bring it to the vacuum. And after machining, and even if we have a lot of separated parts in the nesting, we want to be able to pick it all in one go and bring it back to the storage. So the idea of this head that is mounted on this big industrial robot is there is a blow force that comes on the sides, and by blowing towards the sides, it's creating a vacuum in the center that then makes sure that one sheet of the vacuum cart is being picked up. So that's down here, there's like a stack of vacuum carts, and with this principle we are sure that it's only picking one at a time and not the full stack, other than on a regular vacuum. So it would pick that up, bring it to the vacuum plate, to the work holding, and then go to this big compartment here where we can store multiple plates, multiple thicknesses. So we have one, like the upper side is the one with the stock material, and down here we have like the finished parts, the finished nestings. So the robot gets here, grabs the plate by vacuum, by regular vacuum, just like our work holding vacuum, brings it to the table. We have a demonstrator table here now, but it would work with all machines, no matter it has an automatic side door or front door. This depends on kind of the layout between robot and the machine. So the idea is, in kind of a rotation or rotary angle, we can have multiple of these storages and magazines for different thicknesses. So no matter how big you set your program up, you can then select a 5mm plate is getting loaded into the machine for the next 5 jobs, and then we switch to a larger, a thicker plate to work on with this. So let's take a closer look at how this thing works. We hope you enjoyed this tour and the innovations around just as we do. Thank you for watching, and now enjoy a few impressions of our this year's Tech Day. Thanks.